Hello, everyone. It's our first presentation as a 2600 community here in Foo Café. We're super glad to be here. I hope you enjoy being here with us today. We will see that close to the end of the presentation. Maybe you find that boring. Our event is sponsored today by Capish. We would like to say thank you, and maybe you want to give a word, right? If you want to, please.
Hello. Nice to see that so many people has gathered here Friday night. I don't know if that's worrying or not, but you're very welcome. I work for Capish. It's a software company right across the corner from here. And usually I just say something, please enjoy the pizza, please enjoy the beer. And the reason why we sponsor Foo Café is more a charitable thing, because we like to have an open, alive forum for developers in Malmö. And this is the best. But today I actually have an agenda. We're looking for people, great developers. What we do is, our frameworks are not very rare. We use .NET and we use JavaScripts, but what we are creating is quite unique. We make a data analyst tool for clinical trials. They spend millions and billions on getting data on patients, how they react to medicine, but they only care for yes or no if the data has, if the cure has effect. But what we do is actually enable them to use the other data to make better discoveries. So if you want to work with something that actually prolongs life and gives better quality of life, you're welcome to talk with me in the breaks.
Thank you. And it's probably time to start already, yes. So what the heck is a 2600? 2600 is a community, first of all. It's a community of people who would like to learn, who love sharing the knowledge, and yes, that the battery is looking good. Saying something, still not. No?
Say something.
Something. No. Aha.
It works.
All right. I can. Yes. Yeah? Yeah. Good. Sounds good. So, 2600 is a community. It was born in 1984, quite a long time ago, as a magazine about IT and more recently about hacking. You can find it probably everywhere, and if you haven't heard of it, that's interesting. But what is more interesting than that, that's around that magazine. There is a community of people in most big cities around the globe. So that community is meeting every first Friday of every month. So if you, I don't know, on a business trip in New York, for example, there is very high chance that if you will look around for 2600 community, we will find a gathering of people who will be there for in the first Friday of the month. And that's nice because you can meet new people who is like-minded like you and have the same interest. And so, yeah, why not? So we're here to share maybe some knowledge and give some presentations and have chats in a break and after. And yeah, if you're here, you already a part of 2600. So yeah, hooray! It's our first presentation, as I said before, here in Foo Café, but we're here to stay, I hope. We'll see. But if you would like to join the next sessions, that's what you could expect. I myself working as a penetration tester and learning a lot of things security related, so I will be presenting, I think, quite often. We will see. And my presentations will be mostly about different hacking techniques and different, I don't know, whatever future will bring us. But if you would like to join as a speaker, you just drop in with the subject that you have in your mind, and that's about it. We add it to our Trello and you're good to go. No restrictions about that. Was there a question? Cool. So we believe that sharing is caring, and according to internet, this is a quote of that guy, but according to internet, every second quote is from him. So the idea is that if you can't explain something simply, there is a chance that you don't really understand it. So that's the idea of the presentation that I will give, because a few months ago I had very vague understanding of what that is and how that works, and then I took the topic, did my own research, and basically we shall share my homework today with you. It will be not like 100% top skill pro that could answer any question, but we have many of us here today, so maybe some of you would be able to answer the question instead of me, and that's super cool. So if you want to be a speaker, maybe next time, that's also something to keep in mind, that if you don't feel like you're confident on 100% on something, but still think that it's important and you would like to talk about that, that's totally fine. And everything that I say just also is here. I know that many security conferences especially have their very long trial of I forgot the term. Cool. When you need to submit your paper for approval, and for many serious big conference, you most likely will be denied because you don't have much of a social media followers and stuff, and probably will be rejected for many other reasons. But we here don't really care about that. If you have something that you would like to share with peers, that's the forum for that. Yeah, basically bring your open mind to the meeting and spark a conversation, and we hope that that's how it will be growing. Maybe something closer to the format of a conference, where in the start of the meeting we're discussing a subject, and at the end of it we select a date where it will be presented by someone. But more on that later. We have a bunch of links. I will share the slides after the presentation if you want to click on them, because it would be problematic otherwise, I think. But the QR code for the main Telegram group where everything will be happening is here, so feel free to scan it. Yeah, we are ready to jump to the topic of today's presentation, but if you have any questions, that's the time now. Yes, cool. All right, give me a sec. So I know that agenda says that there will be 2 of us today. That's a lie. Today we will talk about fuzzing, and that's about it. Maybe someone here will talk about antivirus evasion next time. Maybe not. We will see. Everything is a work in progress. We have no idea what we're doing, so we'll see how that goes. So we will see how many slides we will cover before pizza will arrive. And yeah, let's start. So what is fuzzing? Fuzzing, also known as fuzz testing, and It is an automated software testing technique that involves providing some random data to the application with the hope that it will crash, to see what could goes wrong. That presentation will be more of a really basic, because I have no idea how tech savvy all of you are, because I don't know most of you. So we will see how technical will be presentations in the future, basically based on your feedback. But that one will be like really 101 for fuzzing and how to set it up and start working with that right away. The term was born when Professor Barton Miller in 90s tried to connect to his Unix system over a dial-up connection during the storm, and storm created interferences in a signal, and machine acted weird. So he asked his students to try to simulate that behavior, and they came up with the first fuzzing generator that created randomness, so you could put it to the application and see what happens. It's quite similar to unit testing or any other testing for the normal quality insurance, but the purpose is different. With, for example, unit testing, your goal is to test that everything is working. With that thing, your goal is to test that everything is not working. And more crashes, for the better. There's a few reasons why would you like to fuzz your application or product. First, it's cheap, because you can run it basically on anything. You don't need that many cores. Beefier setup, you have more speed you have, but really it doesn't really matter. You can do that in a cloud on some random server online. It would not cost that much, especially if you're not trying to drain all the resources for the fuzzing itself. It's pretty efficient. A lot of severe security issues were discovered by fuzzing, and according to some academic researches, it's by all means #1 in the technologies that are using right now to discover new stuff, because it's quite efficient in terms of what you can find comparing to like a regular penetration testing, for example. But I will show a few things on that later on. I think I stole that thing from some other presentation, but I don't really care. I just like the way how they explain. So if you will think of the application as a maze, something like that, it's quite a complex structure with like one or sometimes few entry points, and there could be bugs, right? So with something like that, you can take, laser pointer. There we go. You can go from the entrance and find your way to the back, and that's basically how fuzzer will do that. And that will work for many bugs, but not all of them, because some of them don't really have a connection to user's input. So it's great, but it's not a silver bullet. That's what I'm trying to say. There are few types of fuzzers nowadays. It probably doesn't really matter right now for the sake of that presentation, but we will talk on their difference just a bit. But it's like a science by itself, and a lot of academic research going on all the time around that topic, and some of them are really mind-blowing. Fuzzer could be super simple, like you take in stuff from def random and throwing it to your target, and target is crushed. That was fuzzing. That's it. It's not reproducible, really. You probably would struggle with that way if that's your main approach, because you somehow need to validate that and, write the report. But that also could work. That also could be considered as fuzzing. There are really many fuzzers nowadays. A lot of stuff is going on around American Fuzzy Lob, also known as AFL. There are several major branches: IFL, IFL++, and WinIFL. IFL was originally developed by Google, if I'm not mistaken. IFL++ is like a major fork with more speed and more everything. And WinIFL is the same thing, but for binaries in Windows. libfuzzer normally used to fuzz libraries. OSS fuzzer is like open source thing because you can fuzz many different things, right? And OSS fuzz normally looking for the source code as well. And the meta, I forgot, but that doesn't matter because today we mostly talk about IFL, and IFL stands for American Fuzzy Lob, and that's that cutie on the picture. I have no idea why, because it's make a lot of people confused when you're trying to Google it. But from what I heard, that little bunny is used to dig into things. Like if you will close it with the cage, it will try to dig underneath to escape. So that's why, but whatever. Google and their naming. I don't mind. They have a great example in their website about how they try to fuzz application that reads JPEG images. So they create a directory, echoing hello into that directory as a file, and starting fuzzing. In a while, IFL creates add-on of file with the valid JPEG header based on the response from the application. It tried to understand what application is needed, and that sounds like a magic. I'm still not sure that it's not a magic, but AFL is open source project. You can go and check the source code, but it still sounds like magic to me. In this particular demo, we will look for open source projects because first, why not? Second, is really underlooked how important open source projects are. And you probably know that if you work in a security field and recently had log4shell issues, because everyone has, and that good old meme explaining it really well, because that was exactly log4shell and log4j bull. So by doing that, you're doing several good things, basically. You secure in the world, why not? You're helping the small project without a budget to do good things and find the security issues in their product. And you also, I don't know, upskilling yourself. There's a few other ways how you can benefit from that, but we'll talk about that later. Because when you find your crash, for example, you would like to report it, right? Because there is no reason to have it in your hands and the world would not know about that. You of course can do it over GitHub, for example, where you find your project. But there is also quite new development called 100F. You can sign in with your GitHub account and report the issue there, and they will help you register it, find the correct people to talk to, and they could issue a CVE, which stands for Common Vulnerability something. I forgot. It doesn't matter really. It's a cool thing to have in your CV if you work in a security field. That's all that matter. And they also paying bounties, and the bigger your target is, more likely you will get paid well. Honestly, I was expecting to go through those slides in like half an hour, and it's just 10 minutes. Alright, it's time for a demo. We will be looking at CVE from 2019. I have it somewhere here. it's not so severe, but the goal of that exercise was to try to find the same issues that someone already found based on the what's explained in the resources like CV details, and do that via fuzzing. And yeah, goal was to do it in open source. So, pointer. No. All right. We will do that in instance of Kali virtual machine that I somehow need to fit into the screen. Would that work? No. Oh well. That's embarrassing. Let me check. It's also supposed to stretch. Would that work? No. Oh well. Oh well. It's even worse now. Sorry. Give me a sec. Yeah. But if I will not find the solution in a few seconds, we will do without it, so just stay with me. Whatever. So, as I show, we will be working with software that's supposed to work with PDF. We have a few just dummy PDF files to work with. So fuzzer will check them. Can I open? Thank you. And try to change those files in order to make application crash. The application that we will be fuzzing called XPDF, and it's the version of it from 2019 where the issue was discovered. It's fixed in the latest version, but our goal was not to compromise something currently, but more to learn from the previous findings. But yeah, you can do it with the different application and different versions, of course. So we already have FL installed, and as I thought that this presentation would take longer, this is already prepared machine, so yeah. And I also thought that it would be quite boring to see me copy-pasting commands from my notes to the terminal and waiting while it's done. So it's pre-set up already, it's already installed with FL++, and the application is already compiled with IFL. So the basic idea is that you have your source code, and if you compile it with GCC or something, you will have it just running. But if you will compile it with IFL, IFL could actually work with that to see where application takes turns and stuff like that. So I will just paste the command, and it basically takes those PDF examples and using... Sorry? No, I get it. I will try. Yeah, so it takes PDF examples from the folder, it takes directory out as an output, and that's it. We just press enter, and it's starting. Too small. I don't remember. Later on I will share the slides, and there will be explanation for everything if you're curious. But right now we got AFL++ running. There is a lot of things going on that screen, but I will try to briefly explain what some of them means, at least the important ones. So you can see the timer. According to my previous tests, it will take about 20 minutes to crush that one under the current setup. And we will later on check why did it crash and can you do something with that, like is it exploitable or not. As our goal is to find a security issue that you can exploit and leverage that. You can see right now what is going on that part of the screen. It's trying to slice. AFL can do a lot of different things like trimming, slicing, so it's basically take the structure of the file or whatever applications need to use and do random stuff with that. Sometimes it's just flipping bytes. Sometimes it's just changing the structure. And the goal is to find the pattern that will make application work not the way it's supposed to do. You can also see percentage and how many executions you have and execution speed. More execution speed you have, more likely you will find something quicker before you get bored. Normally I'm starting to once we'll be done when it's already 1 minute, but it takes hours sometimes, and that's fine because if that would be that easy, everyone would do that, right? But sometimes it takes hours, sometimes it takes days, and we already got crash. Oh well. But yeah, let's go through the interface first. So we have on the right side overall results, cycle downs. It's like when it tried every possible direction in the application, it will be 1. Normally it's recommended to wait until at least 1 full cycle before you stop the fuzzing. When it's crashed, you get that nice red 1 or whatever that will be. The more robust application, more time it will take to crash, of course. And if it's hangs, you also get the notification that you have hangs. Later on, you can work with the logs to see why it crashed, what was the reason, and stuff like that. As you compile your application with AFL sort of know the map of the application, so that's the way how they measure cycles, and that's the way how it's calculating how many percentage from the old map is covered. And that's about it. You can run it in many cores. You can run it as a setup where you're running like 10 fuzzers at the same time, maybe at the same target, because the result is random. It's hard to really rely on how many of them you need. And I know that most people running like 4 to 8 fuzzers, depend on what setup you have. So yeah. Any questions so far? We have a mic somewhere. Thank you. No. I mean, I can. They can't.
Okay, now
Yes,
better.
that's
Yeah.
good.
All right. So I've seen a lot of people using AFL, and a lot of people having files as input. Is it possible to test with AFL when it comes to like network protocols as well? And how would you go about doing that? In that case?
That's basically the reason why there are so many fuzzers, because you can try to use something general like AFL. It's mostly for binaries, Like for libraries, you have libfuzz. For network protocols, you have something that I don't remember the name of the fuzzer right now. Like you can do it, you can write your own thing, but yeah, basically, if it's a binary that takes files as an input, you can just use IFL that way. Otherwise, you can write a harness around the application that you need to use and run it over the IFL, for example. Or you can use the more fuzzer that is more oriented on what your goal is. But generally speaking, you can use IFL to run network protocols. Maybe it will be slower, maybe it will be not that accurate as fuzzer that was written to fuzz protocols, but yes. From what I tried while preparing for that presentation, you can, for example, have GUI applications where you need to click stuff, and you're just writing the harness that will click stuff for you, and throw that into IFL, and will click random stuff on the screen and restart if it's crashed. So everything is possible, but maybe it's not the most efficient way to do that. So yeah, when you're choosing the target, you might want to keep that in mind.
Okay, thank you.
Anyone else? Yay.
No? No,
Yes.
sir. Okay. So, if I understand correctly, now it is compiled using the AFL thing. But what exactly does the AFL compile into it? Or not exactly, but like, you know, in a brief. And also, would this work then on a random binary? Like if we're doing the XPDF without compiling with AFL, would it still work? Because I guess it's still the same thing. If you put some random stuff into it, it will eventually crash.
Yeah.
Or what does the compiling part do?
The compiling part adding different instrumentations into the binary. So that way IFL, while running it, will know what exactly is going on and try to like make a map of it. You can also fuzz stuff without compiling it with compiling from IFL, for example, but that way you will not have instrumentation, so IFL will just shoot random stuff on it and that's it. You will just wait and had no idea where you are and how many cycles there are and stuff like that. But that's probably it. There are a few different options how to use IFL without compiling stuff, because sometimes you fuzzing not open source, for example, and you don't really have stuff to compile. So they are there. So it is possible to not compile with the IFL compiler, but basically it's GCC with other stuff that adds to the code some markers, so IFL will know where exactly that function is. I had an idea to show like how application look like in, for example, IDA Pro or Ghidra or whatever from the graph view. So compiler for IFL is doing the same. It's just marking those branches and to know where they are. And that basically is. But under the hood, if I'm not mistaken, it's just GCC still. All right.
Should I give? Can you guys hear? Perfect. Yeah. So basically, for what I understood, and for most of the fuzzers, just helping answering the question.
Thank you.
He had most of the fuzzers. They basically work just like an antivirus work. You know, like so when you compile it with the NFL, what's gonna happen is that NFL will map all the input. You know, anywhere the application has any kind of input, if it's a network or if it's a file, and it needs to have an I/O input, it will map those API calls. If it's a Windows or if it's a Linux, then the system call for that API, and will add a hook to it. So when you run the fuzzer, it will go to those hooks and feed random data, right? So it's basically the same the antivirus does. So when you develop a virus, you know, certain API calls, when you compile it, certain API calls will have a hook, and that's how the antivirus knows those calls were made and can, you know, define a profile if it's a virus or not. But it's basically the same way the fuzzer will work to define where it should feed random data to see if the application crashes, I guess.
That is correct. Thank you. If you have too many files, it would take longer to crash. So, oh no, you would like to minimize the flow that you're working with. Normally, as we saw with the hello example, it could be just anything, and that way you will hope that at some point it will crash. But if you have some files, for example, just with a plain text or empty one or one with a picture, you kind of feed different data type and data structure to the fuzzer, and it will play with it because you have no idea where the bug could be, and that way you're providing different raw materials to fuzzer to work with, basically. Four crashes already. Last time I had to wait an hour to get 2, and now 5. Okay, I guess we can stop.
One brief question.
Sure, yes.
Is it possible also, if there are like hooks on each function, is it possible to fuzz individual functions in order to?
Absolutely, yes.
Yeah.
If you know what you're working with, and that's the benefit of working with open source, you can read the code and understand what you're doing. And normally, I could be wrong, but from what I did, you're just writing the hardness to do exactly what you want to do and throw that into IFL. So it will start not from the just importing the file, as in that case, but if like doing that type of function that you would like to test. But general answer would be yes. Anyone else? No? All right. So we have a bunch of crashes. Now if we will go to the folder, I think just the folder will be more intuitive way to show it. We have out folder, and there probably could make it bigger so you would see. There's a different folders and stuff that explain what's going on, what you've been working with, because it's quite a standard procedure that you start fuzzing and doing your other stuff, or just starting to test your target manually while you kind of running that in the background. So those setups will help you remember what your setup was, what you was working with, and stuff like that. For example, in the thanks folder, you can find those files that for some reason make the application hang. So something there is not crashing it, but it's not stopped to responding. And in the folder with crashes, a juicy stuff here. So as you can see, it's not even rendering as a PDF anymore, but those are PDFs. And if I'm not mistaken, here in the README file, you will see what exactly. It's also too small. Let me fix that. They help you remember what the command was, and trying to also remind you what's the setup and stuff like that, and what you need to do if you have any issues. But we will be looking at all of those files. Maybe one will be enough, because I know there's only one issue in that version. So let me see. Lost my mouse. Yeah, it's here. So if we will go to the application, and it is in XPDF folder, if I'm not mistaken. So there is file somewhere, and the IFL was running that file. and I don't have it in my notes where exactly it is. That's also embarrassing. XPDF? No. Damn it. So it's called PDF to text. It's supposed to be here. Yes, it's here. So PDF to text. And that basically was the function that we were using while testing, and I forgot to mention that. And we will basically throw the file from the crash directory to see what happens, to see will it be a segfault or something else. It's supposed to be a segfault because we were hunting for the memory corruption bug. And this binary takes files as a standard input basically. So we will be specifying out. Yes, sec. We will take the first one. See again. For example, that one. And as you can see, it crashed, and it crashed with the segmentation fault. So what we will try to do now, we'll try to explain why it got crashed, and we'll also go to the debugger to see if there anything we could do about that. So if I'm not mistaken, we can run GDB on that PDF to text. So uncomfortable to type and look back. I will need to think of that next time. Sorry. Yeah. With the file. I also don't have that exact thing specified in my notes, I'm sorry. That exact part is missing. I am looking for out, yes, thank you. No, it will be default crashes. C, that. C, crashes. Yes. Am I doing that right? I hope. If we will do a backtrace, T. Now stack. I'm doing something wrong. Of course. Thank you. And oh yes. You see, that's why there are so many of us here. It was out default crash, not X, C. No, why? And the first one will be ID something. No. Do something. Oh yes. 0, 0, 0. comma. It's not auto-completing. Ah! Let me copy and paste it. GDB. Thank you. So, what we are seeing here is a segfault. I will try to make it a bit more bigger. So, it's segfault. We could backtrace it, and we will see that many times it repeat why exactly it got crashed. And I can't see that right now. Oh no. It could be not. Yeah. Cannot access the memory address. Yes. Looks correct, but I don't see the key function that we're supposed to see.
You can continue by there's more.
Yeah. I'm just was looking for this lookup. All right. Yes, it's just me overstressing the whole thing. If we will have a look on the CV says that the parser of getObj function in parser.cc have an issue in that version. So we've potentially found that stuff, and we could just check if we could do something with that, like maliciously from the attacker point of view. We can source. There's a plugin for GDB called exploitable. It will basically do a super simple analysis for you, so you won't waste your time for complete garbage that you can't nothing really do about. And I will also add link to the slides before publishing them. It's in the same folder. No. Exploitable. Exploitable. No. Oh wow. Exploitable Pi. Now when we have it connected, we could type exploitable, and that will call the whole thing, and it's normally supposed to also have a color here, but basically it says if you can exploit it or not, and it says yes, and it's also give you some pretext on what are you looking for with that part, that type of crashes, and what you could try to achieve. But yeah, it's like really basic testing for where you have a crash, but most of the time it's enough to work with. And that would be the end of presentation, and that's supposed to take me some more time, but now we will have our pizza and beer. But if you have any more questions, I think it's the time. No? Yes? Yes, please.
All right, so when it comes to exploitable, I haven't heard of it. How good would you say it is in detecting whether or not it's exploitable, or is it a lot of false positives, or?
It depends. It depends on what the target is, but with most binaries on C and C++, it's working as a charm. But if it's something more sophisticated and high-level language, it's sometimes not that easy to work with, or maybe it's not working at all. I don't recall. But it's, I don't know, I tried it a bunch of times, and if it says it's not exploitable, I'm normally not wasting my time on that. And if it says that it is exploitable, I don't recall any of those being false positive. So it's maybe the target that was testing with, or I don't know, but that's the reality, at least based on my experience. So
All right. Quick follow-up on that one. When it says exploitable, I mean the CV, it said it was a denial of service attack, basically crashing. But could you leverage that one besides crashing the application?
I was trying another sample of the application that was vulnerable against buffer overflow, and there it was developed to the full-blown exploit where you can get a shell and everything. But I thought it could be too much for the first session because I had no idea who will be here and if you would like to see such details or not really. But yeah, in that one, it's probably that you can create a file that you can send as email, and that will be denial of service, but really.
Yeah, as you can see, the exploitable, it provides an explanation why
Yeah,
it's
some
exploitable.
pretext.
And then you can see there that basically what happens that you have a stack overflow, right? So there are bytes that overflows the stack, bypasses the EBP, and goes to the return address, right? And when you try to read the return address, it's an invalid address because it's a low address, and the low address are access violation because they're reserved for the BIOS during the boot process, right? In the 16 bits, well, it's not still in the protected mode. So like you have to take into consideration whenever you're doing any fuzzing or you're trying to exploit something, that most of the exploitations nowadays don't happen because of one vulnerability. Even though it says it's exploitable there, you still have to consider, is the application compiled with stack protection, canary is enabled and all of that. So generally speaking, you have to have more than one vulnerabilities, and you generally have to do return until EBC and all that before you actually exploit. So yeah, that's I think.
That is correct, yeah. I was choosing that target because the exploitation is simple and because it was crushed quite quickly, and I thought it's easy to explain that you work with files, and if you will generate a bad file it will crash the application, so that. But yeah, maybe it was a better idea to use something like the spawn shell or something. But we have that in plans in our trial report to do a presentation about when you got that crash, how to go from that to the spawning a shell basically. But we will do that if you want to see something like that, or maybe you would like to present something like that. Yeah. Anyone else?
Verify if it's actually vulnerable and if it's actually exploitable is now to verify the address, to do a debugging and see when it stops, when it gets to the segmentation fault, what is in the return address, and see where in the the bogus file that the AFL created that person is, because that's where you would have to inject your shell code, right, to get reverse shell or remote code executing or whatever, or privilege escalation depending on how the application is run, right?
I was just wondering, when do you consider that you are done fuzzing? Like, I've had it running for 20 days. Is it secure? Like, what's the threshold?
There is no threshold basically. You're running it until you find something, and as you can see, there's 4 more crash files to inspect, and if none of them is not giving you any juice, then you going on until you find something, or you're like, nah, I'm tired. I don't want to spend time on that target anymore, or considering that it's okay. But if you have crashes, it's not okay normally, because that's probably the main difference between that and more static analysis, because if it's crashed, it's crashed. There is hard to be something like false positive because it crashed the application. It could be that it's crashed the application, but it's not exploitable, and that's okay. You can do nothing about that. But yeah, normally you can leave it running, and if that is used as a part of, I don't know, penetration test, for example, you just keep that running and doing all of your normal routine tasks.
Good summary for the event.
Ooh. We have last question.
Yeah, I just wanted to add a comment there that this tool seems to be very well suited to the attacker, and maybe because of the open-endedness of when are we done, it's not as helpful for the developer. Maybe the attacker's advantage, giving a beautiful edge to those who only need one single hole, whereas the
Yeah.
defender needs to cover all angles, of course.
Yeah, like if you're fuzzing that as a developer for your product or application, you probably would like to do it not on a everyday basis or every release basis, but time to time, and to see if there are any crashes and what you can do about them. Because if in that case you have your source code and you can see what went wrong about that, because you have those files, you have logs and everything, and you fix it until you fix it. Yeah, if that's it, we could wrap up and enjoy our pizza.
Thank you.
Thank you.